Hey everyone, this is Math 116, section 3.3, and this is going to be solving systems of linear equations again like we did back in chapter 1, except this time we're going to be using matrix notation versus just kind of keeping the equations intact and doing elimination. Math-wise, it's very, very similar. It's still elimination method. This is a little bit more structured, so let me go through some of the vocabulary and just sort of the general idea of what we're trying to do. So if we have a matrix, and let me grab this example right here. So this will be the first one I do in a second. We're used to seeing it look like this, a system of linear equations. When we write that in matrix form, it looks like this. It's the exact same thing. We're just leaving off the x's, y's, and z's. So this became 1x is just 1, -3, +2. The line stands in for the equals, and then 11. So this is just the equation form in the matrix form. So when we're back here looking at sort of what we're trying to do, that's what these matrices are, it's just systems of equations. So we have kind of two places we can get to in terms of solving. The first one is called row echelon form, the second one's called reduced row echelon form. For row echelon form, we have ones along the diagonal, so this would be like z equals this number, y plus something equals that, likewise x. If we get it down to this spot, once we know z equals that, we can plug it back in here and figure out what y is, and once we know that, we can plug it back in here and get what x is. So we can't actually stop when we get to right here, and then just do our back solve. Reduced row echelon form, so this is what I'm going to show. This is a little bit more work. We get those zeros in the corner, we get the ones down the diagonal, but then instead of having these values up here, we get those to be zeros, and then this just reads x equals that number, y equals that number, z equals that number. So this is like the full solution version, and this is the stopping at back solve and then flipping over to sort of going back to our old algebra version. I'm going to do a bunch with reduced row echelon form just because that's kind of what they show in the book. You can go to here and then back solve and stop, so I'll just put that out there. For row operations, we can interchange two rows, which we could do back in chapter 1, but we didn't talk much about it. But in this case, if, say, my, like in this example, I want a 1 right here, so say these two equations have been written in the other order, I could just switch those around and get myself that 1, which is what I'm shooting for, is the ones on the diagonal. I can multiply a row by a constant. We saw that back in chapter 1. We'd multiply the row by something and then add it to some other row, which is the third thing we can do, which is add the product of a row multiplied by a constant to another row. So we can add rows together, we can multiply them by something, and we can switch them. It's kind of our three tools we have. And so then sort of the steps for solving these, and these are not hard and fast steps, but this is just sort of at least somewhere to start. Step one is to, and this one you pretty much want to do, is use row operations to make a 1 in the upper left-hand corner of the matrix. So we're getting a 1 here. Usually there's a 1 somewhere in one of the equations, so maybe we can flip this around. If the first equation doesn't have a 1, maybe one of these ones does. But so we want a 1 there. And then our second step is to make zeros under that. So what we're going to do is eliminate x twice. So this is basically like our equations 3 and 4 from back in chapter 1. Once we have that, we get a 1 in this spot. And that one right there, I'm a little like, sometimes I leave that a number, because if you make it a 1 immediately, you get fractions sometimes, which isn't so great for working down here. So a lot of times I'll leave that a number and then get this 0 and then make that 1. And then from here we can back solve, or we can keep going and get these upper zeros, which we do by using this z to knock out those two, and then that y to knock out that. So it's like we kind of go this way, and then we go back that way. So let me show you what all that's going to look like with an actual example. And these are super long, so sorry, this is going to go a bit. Okay, so this first example, I just, like I said earlier, set up the system's equations as a matrix here. I already have that 1 up in the corner, so that's what we're looking for. And so now I'm going to use this 1 to knock out that -2 and then that 1 below it. And the way these things are is this is now going to be row 1, row 2, and row 3. I used a little less formal notation when we were back in chapter 1, and now I'll kind of show the full-on version of for the matrix notation. So what we're going to do is we're going to go 2 times row 1 and add that to row 2, which is going to knock out that negative 2, and that's going to make the new row 2. So the way that we say that is 2 times row 1 plus row 2 makes arrow the new row 2. So when we're using lowercase, we're talking about what operations we're going to do on this matrix. Uppercase means what it's going to replace in the equation when we plug it back in. So the step I'm about to show, you totally don't need to show. I just kind of find for teaching it, if I don't show the arithmetic that I'm doing, people have a really hard time following it. So I'm going to do some scratch work over here, and then I'll put my answer back together as a matrix after I finish my scratch work. Scratch work, absolutely not necessary. If you can do it in your head, that's cool. These things are kind of sign errors waiting to happen, though, so there is sort of an argument for writing a little bit down. So 2 times row 1 is going to be 2, negative 6, 2 times 2 is 4, and 22. And then we're going to add to that row 2, so negative 2, 4, 1, negative 3. And so like I said, you could kind of go 2 in your head. 2 plus 2 would make, 2 minus 2 would make 0. So you can do all this algebra or this arithmetic in your head and just be putting this straight into the matrix if you want. Here we got negative 6 and 4 makes negative 2, 4 and 1 for 5, and then this makes 19. So that's going to be my new row 2. I'm going to go ahead and get a new row 3 also before I rewrite all this. So I'm going to go row 1 plus the negative of row 3, and I could also say minus row 3, but I'm going to multiply a negative through just because it's easier to not mess up signs that way. And that's going to make the new row 3. So row 1 right here, and then the negative of row 3. So negative 1, positive 2, negative 3, negative 12. So here's kind of my scratch work for that. And I get this. So this is my new row 2, this is my new row 3. So now I'll rewrite the matrix so I can kind of see what I got. So 1, negative 3, 2, 11. And then there's my new row 2, 0, negative 2, 5, and 19. And here's my new row 3, 0, negative 1, negative 1, negative 1. And so now we got our 1 and a couple zeros here. So now this is where it wants us to get a 1 right here, is sort of usually what they would say. But to me, if I divide all this by 2, then I have these fractions, which is going to make this part harder. So I would get that 0 there, and then I would make that into a 1. So this is going to be row 2 plus negative 2 times row 3. That's going to give me a plus 2 here, minus 2 there. And then that's going to make my new row 3. So again, all this over here is just scratch work to show this. So row 2 is 0, negative 2, 5, 19, and then negative 2 times this, so it'll just be 2, 2, 2. And so from there I got 0, 0, 7, and 21. And then just because I don't have a ton of space to do these things in, I'm going to go ahead and do an operation on this before I put it back in. And that operation is going to be 1/7 of row 3 makes the new row 3. And so what that will do, let me get my row 1. So when I go 1/7 of this, then this becomes a 1, which is what I want, and then 7 goes into 21, because this is really just 7z equals 21. So this is just like dividing over the 7. And so that will make a 1 and a 3. So from this point, I could really back solve, because right here I know z is 3. This is just negative 2y plus 5z equals 19. So I could put the 3 in for this z, bring that over, and get my y. And then once I have that, I can put x and y in here. I'm sorry, y and z in here, and then solve that for x. So that would be if we did the row echelon form. The book shows reduced row echelon form, so I'm going to show that. But do know at that spot, like if it was on the test and it said solve using matrices, at least in my class, if you got to right here, I'd be happy, and then you could back solve. But here is the whole problem. So now, and this is that thing again where I don't love making this a 1 immediately, because then again I'd have fractions here. So what I'm going to do is I'm going to go -5 times row 3. And I'm going to add to that row 2. And that's going to make my new row 2. So what I'm doing is knocking out this 5. So that would look like 0, 0, and then -5 and -15. And then this row is 0, -2, 5, 19. So 0, -2, that's gone, makes it 0, that makes a 4. Okay, and then I'm going to do the same thing I did on the last one, which is I'm going to divide this over. So I'm going to go -1/2 times row 2 to make my new row 2. And that's going to get me a +1, and it's going to clean this up. Okay, so here it is written out. So I just copied down my old row 1, and then my new row 2 is going to be -1/2 times that one, so I could get this to be a +1, and then that made that a -2, and my old row 3. So then I need to knock out that 2 and that 3 if I'm going for reduced row echelon form. So to do that, we're going to go row 1, and then -2 row 3, or plus the negative of 2 row 3, I guess, is going to make my new row 1. So that would be 1, -3, 2, 11, and 0, 0, 0. Okay, so what I did was I just copied down row 1. Here's row 2 multiplied by row 3 multiplied by -2. Add those together, I get 1, -3, 0, and 5. So that's here. So now I have that 0, so now I need to make this 0. So we'll go row 1, and then plus 3 row 2. And that's going to make my new row 1. And then this times 3, so 0, 3, 0, 3 times 2, -6, 1, 0, 0, and -1. Okay, so here's the final on it. I just copied over my new row 1. So this just means z equals 3, y equals -2, and x equals -1. So our solution set would be -1, -2, oops, positive, sorry, ignore that, 3. Okay, so examples 2 and 3 are the ones I would have you guys try in class, and so far I just took this and wrote it as a matrix. And I think since I did the reduced row echelon form in the first example, I'm going to do row echelon form in this one, and then back solve just to kind of show you both flavors. Okay, so I'm going to do the same thing I did in the first example where I'm going to use this 1 to get zeros here. So that's going to be row 1 plus, we're going to go the negative of row 2, and that's going to make our new row 2, and then we'll go -2 row 3, or row 1 plus row 3, and that's going to make our new row 3. So I'm just going to set that up over here, and then I'll be back to show the math. Okay, so here's the first operation. And again, these are things that if you can do them in your head and not make errors, I'm not the best at that. But if you can just write that this is what you're doing and then go straight to writing the matrix and not show all this arithmetic that I'm showing. So here, 1, -1, so that's our 0 we're looking for. -3, -1, and -2. So that's going to be my new row 2. That was this step. And then this is -2 times row 1 and plus row 3. So that's going to be our new row 3. So 0, -1, 4 minus 2 is 2, and -3. And now I'll just rewrite the matrix with this is row 2 and this is row 3. So now I'm going to do like I did in the last one. I'm not going to make this a 1 yet, just because I'll lead to fractions. So I'm going to get rid of this first. And you'll see coming up in chapter 4, we're going to do some work with matrices that we do have to work with the fractions. It's just unavoidable. But here where we don't have to, I'm just trying to make it a little bit easier where I can. And so again, here's what I'm going to do. Row 2 and then -3 times this one is going to make my new row 3. So here it is set up. There's row 2 and then -3 times this made that. And I'll add these together and it gets me -7 and 7. So I think I'm going to go -1/7 of row 3 to make my new row 3, just to get this as a +1 when I write it down. Okay, and here it is all kind of put back together. So row 1, row 2 are the same, and then we made that new row 3, and then I just multiplied it by -1/7 to get my -1 here. Okay, and this was the back solve step I was talking about. Again, I could do a -1/3 through here, but then I'd have to deal with some fractions, which just doesn't seem like that much fun. So I just wrote down this matrix, but kind of back with the x's, y's, and z's. And I think it's just a little easier to see what all the rest of that math was from this form. So z equals -1, we got that right there. I'm going to plug that -1 in right here into the second equation. And then I have 3y minus -1 makes -2. So -3y plus 1, -2, -3y equals -3, divide over, and y equals 1. So now I know z and I know y, so I can plug those back into the first equation, and then that's going to give me x. So x minus 1 minus 2 times -1 equals 3. So -1, that makes a plus 2 equals 3. So x, that makes, plus 1 equals 3. Subtract the 1 over, and x equals 2. So the solution is 2, 1, -1. Okay, so here's number 3. I'm going to do the thing where I get the zeros in these first two positions. So I'm going to go 2 times row 1, and I'm going to add to that row 2. That's going to be my new row 2. And then I'm going to go negative of row 1 plus row 3, and that's going to make my new row 3. So I'll get that set up down here. Okay, so I just set up the math down here. So there's 2 times row 1 plus row 2. So that will make a 0, -1, 2, and 4. And then this is the negative of row 1 and then plus row 3. It makes 0, -1, 2, and 9. So now I'll rewrite this matrix with those in there. Okay, so here's the matrix rewritten. There's my first row and then second row, third row. And now I'm going to get a 0 here, so I'm going to go the negative of row 2, and I'm going to add to that row 3, and that's going to make my new row 3. So here that is set up. This is the negative of row 2 and then plus row 3. And so then we get 0, 0, but then we get 0 again, -4, so that'd be a 5. So what this looks like is this. So I've just rewritten this into the third row. And so you can see this is no x's, no y's, no z's, somehow make 5. So this is like that 0 equals 5 solution, which is a no solution, or the system is inconsistent. Okay, so for number 4, the first thing I did when I rewrote this is I swapped rows 1 and 2, so I'd have a 1 up in this first position. And now what I'm going to do is I'm going to use that 1 to knock out the 2 and the 1. So I'm going to go -2 row 1, add row 2 to that. Now make our new row 2. And then I'm also going to go the negative of row 1 plus row 3, and that will make our new row 3. So I'll get that set up and be back. Okay, so I did -2 times row 1 right here, and then I'm adding row 2 to that, so that will make a 0, 5, -1, and -5. And then here, this is the negative of row 1 plus row 3. So that's going to make 0, 10, -2, -10. And now I'll rewrite the matrix with those in it. Okay, so here's that with row 2 and row 3 put in there. So now, before I divide out that 5, I would definitely use it to get rid of the 10. So I'm going to go -2 times row 2, and then add to that row 3, and that will make my new row 3. Okay, so here's that set up, -2 times row 2 and then row 3. So I get 0, 0, another 0, and then another 0. So our matrix would look like, and so here it is with just the zeros in the bottom row. So this is what it looks like when it's dependent. And with this version, we like the inconsistent ones better because when there's no solution, we get to just stop. With this, now I have to go back and actually get one of the variables to be my independent variable and then write the other two dependent on that. So I'll show that on the next page. Okay, so here's that matrix from the last page, and now I've just rewritten it with x's, y's, and z's again. And so that 0, 0, 0 thing means dependent. So what we're going to do is we're going to let z equal any number. That's going to be our independent variable, and then we'll find x and y in terms of that. So we're going to let z equal any number. And now I want to get y alone with z over here, so then that will be y dependent on z. So here I will add that z over. And then we divide the 5 out everywhere. So then that's going to get me y equals, those cancel, so I'll write that as 1/5 z rather than z over 5, minus 1. And so now z is any number, y equals this in terms of z, and now I'll go back and get x by substituting this in for that y, and then getting x by itself. So that would look like x and then minus 2 times, this is my new y, minus z equals 3. And now I have to clean that up. So I'm going to distribute the -2 through. And don't forget to get the -1, so I'm like plus 2. And then I think I will bring the 2 over just to kind of get it out of the way. So here I have minus 2/5 z. Oops, sorry, there should be minuses. Apologies. And then minus z, I'm going to write that as minus 5/5 z. So instead of calling it 1, I'm writing it in terms of 5 since I have this, they'll make a common denominator. And then subtracting that 2 over is going to get me a positive 1 over here. And then I'll put those together and get x minus 2 minus 5 would make minus 7/5 z equals 1, and then add that over. So So z was any number, y was this, and then x is this. So that makes my solution set 7/5 z plus 1, that's x. Right here is y, 1/5 z minus 1. And then z is z, because it's our independent variable.